Greetings and welcome to the Chemistry 223 Acid and Base Titrations Lab Introduction, and I'm really pleased to have you here. This lab is kind of fun. It's the first of two labs where we're going to explore in considerable detail how a titration between an acid and base works. In all of these titrations, we will have a base in a burette, and we'll be titrating with an acid which may be known or unknown, and the process is very similar. At the end of this lab, you will have completed three titrations, one of which involves a strong acid, one of which involves a weak acid, and one in which involves a polyprotic acid, and they're all kind of cool, as we'll see. So without further ado, let's get into this lab. In this lab, there's going to be three types of titrations, and it's kind of cool because at the end of this, you'll be able to figure out what kind of acid and base titration you have based on the data that's presented, stuff like that. The first of the titrations is going to be a strong acid plus strong base titration. And what that means is you're going to start with a hydrochloric acid solution and you'll slowly drip in sodium hydroxide from the burette. The graph in the lower left then would show an equivalence point, i.e. where the steep part is steepest, if you will, of equivalence point that should be pretty close to 7, which is kind of neat. And you can find the concentration of the hydrochloric acid or sodium hydroxide for that matter from that point. Because remember, at the equivalence point, that's where the moles of what you add equal the moles of what you started with. So in this case, equivalence will mean moles of HCl equals moles of sodium hydroxide. The second type of titration we're going to look at is a weak acid plus strong base titration, and we're going to specifically use acetic acid, which by the way is the active ingredient in vinegar, so it's something you've probably used before, with sodium hydroxide. And again, the process of this is similar. You're going to use the same equipment, but the information you analyze is different. You can find the Ka for the acetic acid from the half equivalence point. So if the equivalence point takes, we'll say 20 milliliters to get to, then the half equivalence point would be 10 milliliters, and that half equivalence pH equals pKa, which you can then convert to Ka. It's pretty cool. The third type of titration is quite different from the others. It's a polyprotic acid plus strong base. So phosphoric acid in theory has 3 acidic protons. We will probably see only 2 of the titrations today, but it makes essentially 2 equivalence points, so it's pretty cool. You'll check this out, and from that you can find the half equivalence point pHs and the Kas and stuff like that. It's pretty cool. It is important to remember though that because you're starting with an acid and you're adding a base to it, all of your pHs will start out acidic, and they will consistently increase as you add a strong base, i.e. become more basic in this process. So all of your pHs will start off less than 7 and they'll all end up greater than 7. Now in this lab we're going to have some specialized equipment, and the pictures on the left kind of detail what's going on. What we're going to use in this lab is a Lab Quest. It's a type of a little interface that's available from a company called Vernier, and you can attach different types of pieces to it. And we're going to attach to the Lab Quest, we're going to add a pH meter and a drop counter. And in the lower left hand corner, this piece right here, which I'm circling, that's the drop counter. It basically sends a beam of light, and as the drops go through, it counts a drop. So that's basically what the drop counter is. Now, because it's light, you can't have the drops go through too fast, because a stream of drops would look like just one big drop. So it can't be too fast. On the other hand, we are human beings. We don't like to do things too slow. We get impatient. So you want to find that sweet spot between not being too fast and not being too slow, and that'll make it work. Now, the pH meter is the other thing we're going to connect to the Lab Quest. In the lower picture, it's in the beaker, it's right there, but in the upper picture, it's actually in the solution. So you can see in the upper picture, you can actually place the pH meter through the drop counter, and so it gets into the solution, which is pretty cool. And the pH meter will again read the pH values. Remember that all of your solutions should start out acidic, i.e. with a pH less than 7. They'll slowly get more and more basic, i.e. they'll slowly get bigger and bigger as you you add the sodium hydroxide. And speaking of the sodium hydroxide, the base in all of these, the sodium hydroxide will be added from the burette. And the burette is in the burette clamp there. It's kind of vertical. I would recommend starting as a full burette, i.e. at 0.00 milliliters, and you can add it in then slowly through the drop counter so the pH meter can read it, etc., etc. And again, that LabQuest will record it all, which is really cool, and you can see what it looks like at the end. I like this system a lot. It does take a little bit to set up because you have to analyze it just right, make sure you get the right values. And again, you want to find that sweet spot for the drops too. You don't want to go too fast because it can't read it, but you don't want to go too slow either. But at the end, then you can analyze the graphs from your experiments, record stuff on your worksheets, and you'll be good to go. So it's a pretty fun lab once you get everything set up. Okay, at this point, I'm going to show an example of how this works, how the LabQuest system works. You can watch and see and know what to predict that way when you go into the lab yourself. If you have any questions on this or anything else, please reach out to me. I'm happy to help. You can also talk to the Learning Success Center /Avid Center. They're also there to help, and they're pretty cool people up there. Okay, good luck with your lab. Let's watch a video.